Hello, everybody. We are getting very close to starting here, so I just wanted to go ahead and pop on and give you a visual for the attendee panel. So you have a question feature in your panel that allows you to communicate to us. So go ahead and locate that and just make sure that you can send comments or questions. I will put something in here that you can respond to. Otherwise, just sit tight for another minute and we will get started. Okay, everybody, we are going to go ahead and get started. I am turning my video camera on. Hello to anybody who has been on our webinars before and always hears me but never sees me. I am here today with Dr. Skip Fennell, which we are very excited about. I am taking Brittany's place this afternoon because of the inclement weather that has apparently taken over our country. She was stuck at an airport, so I am going to walk you through problem solving and talk about that. And then I'm going to give you a, sort of give you some, let you hear from Skip, who is an industry leading, math educator. He's former NCTM president. We're very excited to have him, and we're going to kind of go through some of the things that make problem solving so important and give you some tips and strategies. I am going to turn my camera off while I go through the beginning portion of this, but then we'll come back on at the end and only do the video. So make sure that you can see it on your screen. It should give you an option to, there's a menu at the top of your panel, and if you're having trouble seeing it, just press the view and adjust your settings. It should automatically show you. The other thing I want to go over is just a couple of logistics here. So this is your attendee panel. You are coming in on mute, and that's just to keep it easy, but you can communicate to us via the question feature. So if you have questions, comments, please send those through. We will flag them and answer them at the end. And I will also be asking a couple things throughout, so make sure that you can locate that and can send a chat. And with that, I think we will go ahead and get started. So let me turn this off just for a moment. Again, I'll be back at the end here. Okay. All right, so we are going to go through problem solving, developing problem solvers and not problem performers. I would like to get a feel for who's in the audience. It just helps us. So I'm going to launch a poll, and that poll should pop up on your screen in your panel. You can go ahead and answer it there. If you don't see it, it's okay. Just chat your role, and we'll do it that way. So I'll give you just a minute here to answer. I should play Jeopardy music in the background, but I don't ever think of that. Okay. So we have about, let me share this with everybody so you can see, a decent amount of curriculum, instructional math coaches, and then a good variation of teachers. Thank you for doing that. I have one more question that I'm going to ask you. So let me launch this one. This one is related to problem solving. And this is, there's no right or wrong answer here. I just want to get a feel for what problem solving looks like or how frequently you're doing it now. Do you have a routine that you're doing every day? Do you not? And maybe you do it in other areas. Would you like to just kind of give me a feel for what your problem solving routine looks like currently? And this can be in your classroom or at your district. Okay, I think we're close here. So we have about half of you almost that say yes, but not daily. And the next closest is yes. So that is good feedback for us. So what I'm going to do today is really just walk you through, what makes problem solving so important? Why, is it that students, tend to struggle with that maybe more than other areas? And what is it that we can do as teachers to really help build the problem solving skills that are going to allow them to, tackle tougher problems and really solve problems in any scenario. And I'm going to walk you through our new routine, but this is not to focus on the product. It's more so to focus on the types of problems that we see and the progression of those problems, just so that you can get a feel for the variation that's going to build strong problem solving skills for students and sort of move them from performer to problem solver. So one of the things I think we all, this is how I remember learning math, and I loved math, but we did a lot of memorizations. And I think sometimes as teachers, we also, tend to correct our students, right? There is a productive struggle element, but sometimes, we give them the answer a little bit early. So too often we give children answers to remember rather than problems to solve. So we're, they're memorizing, they're remembering, we're helping them. And really, we should be looking at mathematics that's not about numbers, it's not about equations, computations. It's really about them understanding the number system, about them being able to read between the lines, if you will, to understand context and look for clues that are going to, give them an idea of which direction they have to go, what algorithm they have to pull in, whatever it may be, really helping them develop a deeper understanding of math and the meaning behind it. So there is a problem performer, and then there's a problem solver. So when we look at, and this is something I think every child does to some degree, because I do think that they tend to start out as problem performers. And, as they build their problem solving skills, we just don't want them to stay here. So problem performers are very operation focused, right? So they're looking at a problem and they are immediately going to, okay, what do I need to do to solve this problem? Thinking about the operation, thinking about the steps. They are often missing comprehension, right? So they're reading it, but they're not comprehending what it's asking. They tend to, work out problems in one way, not super flexible in their thinking. They also often do a repetitive routine. And this is something that I will be 100% honest in saying that I had my students do in my first year of teaching. When we were solving problems, I did have them underline what it was asking, to circle the important information. But we don't want them to rely on that, right? It goes beyond just those pieces of information that particular process is having them identify. They tend to check work by plugging in numbers, and they look for keywords that, sort of, and determine an answer without really thinking to themselves if it makes sense, without reasoning behind it, right? When we look at problem solvers, this is a little bit different. So students who are truly problem solving, they are exploring, they're looking for understanding, they're making sense. They're looking at the problem, they're looking at their answer, they're able to use logic to determine whether or not they're accurate or even close. They apply different strategies because they tend to be more, again, flexible and efficient. They understand math well enough to know what strategies to apply, and then may even use multiple strategies, to solve a problem. They are really looking for important information, not just the pieces of information that they need to solve the problem, not just the numbers. They are visualizing, they are strategizing. Students who have a deep understanding of problem solving and really strong problem solving skills are really able to solve a problem in any situation, no matter how many steps it is, no matter what context the problem is. They are able to approach it with a set of strategies and tools and an understanding of math that allows them to be successful. So this is where
this slide really does a nice job of connecting reasoning to problem solving.
Absolutely. That's Skip, everybody. I should have probably done a more formal introduction at the beginning, but
Sorry.
No, that's perfect. So I think one of the things that we do, and this is sort of finding that balance, right? When you're really focusing on problem solving, because it's not just one thing. There is a process, right? I'm a very process-oriented learner and teacher, quite frankly. And a process is a series of steps, right? So what are the steps that you're going to take to solve it? An algorithm is often a process. And then there's the other side of things, and that's the strategy. To really effectively use strategy, students have to have a deep understanding of math, and they have to have an ability to apply their understanding in any scenario. And problem solving requires both of these. And I think one of the things for us to remember is that there is no trick. There are strategies, there are tools, there are resources, there are techniques that we as teachers can implement, but there is no trick to becoming a good problem solver. Students have to, they have to understand the meaning of operations. They need to understand math as a subject of sense making, and they really need repeated practice applying strategic thinking to word problems. And it is this that will build the strong problem solving skills that they need. And a routine is one way to do that. So I'm going to kind of walk you through the daily problem solving routine that we have with our updated hands-on standards. This is something, I'm so sorry, I have this up. And this is something that is part of our upgrade, and it is a routine that you can implement with anything. It doesn't matter what you're using in your program, in your classroom. It is a quick routine. So let me turn this off 1 second. Oh, it stopped. No, it didn't. Yes, it did. Okay. So this is something that is a daily routine, and it's a series of progressing problems. So I want to, again, focus on the types of problems that you're going to see today, and know that, this is something that you can implement at any grade level for any program, no matter what you're doing in your classroom. And the goal, obviously, is to build problem solving skills, and just in general, a problem solver is a thinker who focuses on the problem and tries to synthesize information and knowledge to achieve a solution. So in our routine, and this is something I think that is a great, a great visual here for you to see this. We go through a progressing series of problem types. So every week, we're focusing on a different skill. So maybe it's 3-digit numbers, maybe it's, adding and subtracting 100, whatever it may be. That week, every problem is going to relate to the concept or skill that's being focused on. And we have a different type of problem each day. So day 1, we start with a video problem. Day 2, we move into multi-solution. Day 3, numberless. Day 4, a single solution. And then on the last day, students create their own problem. So we're going to kind of walk through each of these in more detail. So let me start with the video problem. And actually I have, let me go back just a hair. Okay, so let me go to the video. I want to show you an example of this. So hopefully everybody can see my screen. So this is a grade 2 example of one of the video problems. So this is how we start each week, and sort of launches the skill for that week for the routine. So I'm going to go ahead and let this play. So on the screen there is a pause button. So as a teacher, I can use this video and it's going to prompt me and tell me when to pause. And with the video, there are problem solving cards. So let me show you the cards. I'm going to flip back over here so that you can see this. So this is what the card that goes with that particular problem looks like. So this actually comes in a set of 180 cards. They're double-sided, nice, like 3x5. But when you see the pause button, that's when you start asking questions to your students. So in that particular video, I'm going to ask you, feel free to answer. I can see the chat. What did you notice? What do you wonder? You see, cubes being moved into different piles without any words or any numbers, and just thinking about what you saw visually. What did you notice, or what do you wonder? Okay, so I noticed groups of 10, absolutely. Equal groups. I wonder how many cubes there are, both in total, right? Observed sets. Absolutely. So those are exactly the things your students are also going to be wondering and be noticing. So let me go back and play the rest of that video just so that you can kind of see where we go with this. Okay, so I'm back here. I'm going to go ahead and hit play. So now I'm going to ask you the same thing. What do you notice now with what you're seeing? Or what do you wonder now? Let me see here. 2 left over. Yep. I noticed that there were more equal groups. Yes, the cubes are in groups. Did any of you think about the operation? I didn't. When I look at that, I don't necessarily think about the operation right away. I am more focused on, figuring out what's happening and what numbers might be tied to the problem. Middle group had 9. I wonder why. 14 groups of 10. Okay. So the purpose of this is really to engage students in math. It's reduces the literacy demand. We're not starting off the routine by having them read we're not going through a lengthy word problem. It is intended to really get them thinking about, the pieces that make up a problem. It's not just about being given X and Y and you're calculating them. What's happening here? What kind of a problem could you come up with? Just if you just have this video, and it just gives them an opportunity to wonder and sort of brainstorm with their other classmates about this problem without figuring out, going to immediately finding a solution or immediately going to calculate something. So if we look at the problem solving card that you see here, as a teacher, I have the video, I have the questions to ask. It even tells me when I'm going to pause it. But then I also have, okay, now let's, get base 10 blocks in students' hands, and let's look and have them kind of work with something in their hands. So then we start going through different strategies. How can base 10 blocks be used to model the problem? Show me how you would model the problem. What are different ways to represent the solution, right? So we want to get them, get their curiosity going, but we also want them to see how this translates. Now let's use tools and sort of see if we can figure out what's going on here, right? I know there are 142 cubes because I traded 10 groups of 10 to make 100, just walking through. So the cards are going to be, completely stepped out for you as a teacher. And this is, again, meant to be 5 or 10 minutes. It's a quick routine, and this is day one. So on every day one, we're starting with the video. And then we move into day two. So for day two, we are always going to be doing a multi-solution problem. Okay, multi-solution problem. How many of you, I'm sure actually that's probably harder to ask in the chat. So let's think about multi-solution problems. They do a couple things, right? They, first of all, allow more students to, come to the correct solution. It's not really about one solution. It's about them thinking about the possibilities and, really just giving more students an opportunity to sort of get there. So Jason has 8 red cards and less than 5 black cards. How many cards could Jason have? So if I looked at this, when I was learning, I would probably think that there was something missing, right? But there's not. It is intended to be very open-ended. It's intended to get students thinking beyond, again, the computation. We want them to develop a lot of different right answers, and we don't want the teacher, having a preconceived notion of the answer, because there are going to be multiple possibilities, right? So it forces the students to go back, to reread, to reason, to get to a higher level of thinking, and they're deconstructing the problem before they're solving the problem. And that is the difference between them being a problem performer and a problem solver. So it's about teaching them the habit, right? The thought process of how to approach a problem in a manner that will allow them to be successful. And that happens to be, really deconstructing it and reading between the lines and finding the meaning behind the math. So that's the purpose of the day two with the multi-solution. Then we go into day 3, and day 3 is a numberless problem. This is probably my favorite one. And as a teacher, think to yourself, you're doing problem solving, and I'm sure that these things have crossed your mind, right? They just add all the numbers. It doesn't matter what the problem says, or, they're not stopping and thinking. They just start computing right away. Or they don't even realize that this is the exact same type of problem that we did yesterday. And they don't realize that because they're focused on the computation and they're not focused on understanding what the problem is asking. So if we just look at, numberless word problems in general, we're removing the numbers to help them develop a contextual understanding. How do you teach it? What questions do you have? What information do you need? What is your plan to solve for the question? These are things that, we're asking students. What do they get from it? Well, they gain context for how math is applied. And again, they're focusing on the structure rather than the numbers in one specific problem. So I'm going to show you an example here. And again, these are all just showing you cards. So Jessica had some stickers and she had some moon stickers. Well, my students could come up with 100 different ways that this problem is correct, right? Give me some examples. How many stickers do you think Jessica had? How many of them are moon? Does it make sense? So again, it's about, teaching them that process. And then we move into, replacing them with numbers, right? So this is sort of just to walk you through. I would go from no numbers to, okay, let's say she had 6 star stickers and 9 moon stickers. How many stickers does Jessica have? Then we get to the point where, okay, well, if she has 6 star stickers and 9 moon stickers, we need to do what? We need to add. We're looking for a total. So it's just a different approach. I have, taught a lot of different programs, and problem solving is often, integrated in a manner that's almost, very standard centric, and less about helping them understand the meaning behind the problem and more about aligning a problem to a specific standard. And these absolutely are aligning to standards, but it's really more focused about taking them through a series of problems that will help them approach and think differently about what it is that they're doing. We do also have single solution problems. So on day 4, then the students complete a single solution problem. As they would, but up until this point, they've had the video, they've had a multi-solution problem where they came up with many right answers. They've had a numberless problem where they've sort of done the same. And then now we'll look at a single solution problem. Let me move forward here. I'm on the wrong one. There we go. So again, providing context, understanding, giving students an opportunity to understand problems, focusing on the relationship between the knowns and the unknowns. So there's still a benefit to them having these types of problems. It's just that it's not the only type of problem that they're going to have, right? And then this is the back of the single solution. And every day 5, throughout the entire routine, students are going to create a problem. And this is something that they're obviously going to improve and get better at the more and more that they go through this, and the more that they learn this thought process and learn how to approach. And what we're going to do is essentially give them a visual, right? So I'm going to ask you, if you were given this visual, what might you create? I'll give you a minute. Would this be addition, subtraction? Could it be both? Could it be something else? Proportions. Oh, it could be a comparison problem. I like that. Groupings. It could be all of those things, right? So we give them enough difference between 2 stacks, probability. Oh, I like that. So I didn't immediately think about grouping, but you really could do color, like do a colored and come up with a word problem by that grouping too. A fraction, ratios, data, fraction of total books in the small pile. Yep. Fraction could be blue books to total, right? For each pile, what's the fraction? So you see here, I mean, the possibilities are pretty endless. They can really go in a lot of different directions with this, and I think that's going to depend on the level of understanding that each individual student has, because maybe your learners who aren't as progressed, aren't seeing some of the more complex possibilities here, but I can guarantee that they will see a problem that they can create out of this. Even if it's just an addition problem, or even if it's just a subtraction problem, they'll find a problem, and it will be, that will be just fine, because this is about them creating their own. What do you see, and how are you going to interpret that and turn it into a problem? And I love that, because that's ending the week in a manner that every student is going to be successful, right? And this is the back of the card, just to kind of give you a feel for what that looks like. You're connecting math concepts, encouraging students to look closely at, features of problems. You're giving students a sense of ownership, to really look at the task differently, produce, a different commitment, different outcome, and they're all going to do that very differently. So this is really just giving you some examples for the types of problems and the progression of those problems. And this is, the kind of exposure that students need consistently to be able to really get to the level of problem solving that, they need to be. And, that they're going to be asked to be, on state assessments, those much higher level application, real world context problems. So these are the 5, and I am going to show just briefly. We have a recording page that goes with these. So always a good idea that they're, using manipulatives, that they're recording, maybe it's in a journal, whatever it may be, and they're reflecting, right? So those questions that we're asking them, what did you notice? What did you wonder? What information, whatever it may be, they're recording that, they're thinking through it, and that's helping them to process the information. And this is what our problem solving routine includes. So it's 180 teacher problem solving cards, the ones that we saw throughout the presentation here. There are 36 video problems. Where I accessed that earlier is through our platform. So that's something that you can pull up and project. There are QR codes on the cards themselves as well. But then there's 144 digital format problems that are also accessible online. And then the 36 problem solving activity pages that go with that. So now that we've walked through, I am going to actually stop sharing. Skip, are you ready to hop on?
Sure.
Okay, let me stop showing my screen here. Okay, and I'm going to show my camera, and hopefully I come up. Okay, good. Okay, so again, you guys can put questions in the chat. Skip, I'm going to keep this really simple to start out with. What is the role of problem solving in today's classroom versus, and actually before I even get started, will you just give them a quick intro, if you, just so that everybody knows who you are and why you're here.
Well, you know me well, excuse me, you know me well enough that I hate to do that, but hello.
I know.
My name is Skip Fennell, and I'm a former classroom teacher and a former principal and a former supervisor and a longtime math educator, including serving as a member of the board of directors for NCTM, and also as president of NCTM and president of the Association of Mathematics Teacher Educators, president of the Research Council for Mathematics Learning, and written a bunch of stuff relative to, frankly, this topic and number sense and fractions. Helped to write the principles and standards for school mathematics for NCTM, and also was involved as a writer and reviewer of the Common Core and NCTM's curriculum focal points and so forth. Most importantly, I'm a father of 3 and a grandfather of 9. So happy to be here, and looking forward to questions that she's going to fire at me, and we'll see what
I am going to fire them too. So I appreciate that. Thank you for the intro. So, you obviously were a major contributor to, standards and practices, and you've had a big impact on what the expectation is, or the shift in the math instruction, I should say. So what what is that shift in relation to problem solving specifically? What is it what's the role of problem solving today versus maybe what it was 20 or 30 years ago?
That's actually a very good question, because having taught courses for prospective teachers and also at the graduate level, and obviously anticipating this tonight, I went through a bunch of old notes, and I frankly said, "My God, you taught that? You said that?" So yeah, I mean, I think I view problem solving in the following way, and that is the reason that we have students learn mathematics is to solve problems. That, the higher up they go in schooling, however you define schooling beyond K through 12, they're going to be involved in, engaged in solving problems. And so problem solving is really, very much at the core of what happens in mathematics teaching and learning. But it's not, frankly, the problems at the back of the chapter. It's not, frankly, only word problems. It's not, frankly, problems that have a particular context, whether it's the books that I just saw or how many points somebody's going to score in a game or whatever. There are all kinds of different ways to think about problems and have students engaged in doing problems. And I think that's the key thing. We want kids engaged in doing the mathematics they're learning. I pulled out, I had an old slide deck, not so old actually, slide deck myself. I don't know where I found it, but I had this kid that was playing, and he's got like mud all over him. He's like, and my theme there with that picture was, this kid is into it. And that's what we want kids to be doing as they engage in learning mathematics. We want them into it, and problem solving is very much the key to that.
That's a great answer. Great answer. So along the lines, and I'm just making sure that I am, have these and I'm saying them correctly. So how do then hands-on tools and visual representations impact a student's ability to problem solve? So what might the difference be in trying to build these problem solving skills without those things, without tools?
So glad you asked that. I just happen to have a copy of Principles to Actions in front of me, and among the math teaching practices are two that I'm going to just allude to, and the first one is implement tasks that promote reasoning and problem solving, and so we've sort of dealt with that. You dealt with that actually in the kinds of tasks you presented in the 5-day sequence with regard to the hand-in-mind materials. But then following that is use and connect mathematical representation. So I'm going to read that. Effective teaching of mathematics engages students in making connections among mathematical representations to deepen understanding of mathematics concepts and procedures as tools for problem solving. So the notion of hands-on representations, whether that's a manipulative material or frankly it's drawings that kids create or their work on the number line or on the rec and rec that I saw a picture there, it's a way to validate the problem solving process as well as model it. The connection to the opportunity to have students engaged in representations goes hands in hand with the problem solving process.
Absolutely. And that's something that, and this is an extra, so something that works no matter where they're teaching from, right? Using visuals, using representations.
Right, and particularly now, as you know, I have no idea where all of the audience is from, but for most of us, we're somewhere cold, and in many cases, if you have children, your kids are having instruction online or some level of hybrid instruction, and perhaps face to face. But the notions, the things that we're learning about having to deliver instruction differently online or in a hybrid environment are frankly, there's some takeaways there that we're going to continue to use once, if I can use the phrase, this is over, and we go to some level of whatever normalcy used to be.
Yes, well, wouldn't that be? Yes, I don't know if, hopefully we will return to the normal at some point. So what can, I guess let me ask this first. What are the things that teachers can look out for when they are teaching problem solving, focusing on problem solving, doing something, you know, in their classroom that's regularly focused on it? What are some of the things that they're looking for? Like what do I as a teacher see? What do I hear in students
Yeah.
to know they're on the right track?
Yeah, so I'm going to approach it two different ways. I'll approach it from the planning perspective first. And so as you think about the mathematics lesson that you're going to engage kids in tomorrow, ask yourself the following question: how are my kids going to be involved in doing that mathematics? How are they really engaged in doing that math? I really like some of the, again, the problems you posed, the however minutes ago that was. It really had multiple entry points. And so, and that's a point about the issue of problem solving. So not every problem that you're going to use is going to have multiple entry points, but you know, is that something you want to think about as you think about that particular lesson? So certainly level of engagement is important. And then to your point, what am I looking for? You know, so they're engaged in doing this problem or a collection of problems, or maybe you have an exit task at the end of your lesson that is problem based and you're doing that. So are you looking for the extent to which they're using particular strategies that were an emphasis of that lesson or prior lessons? That's something to look for. You're certainly looking for the extent to which they're engaged in the problem. You may be looking for the need for kids to use particular representation. Are there particular representations they favor when they solve this problem? Do some of the kids just automatically grab hands-on manipulatives to solve that and they're very comfortable with that? Are others, if you will, drawers, and they just need to scratch something out to get a sense of where the problem? All of that is, and it goes backwards. It comes back to you. Okay, as I look at my class, you know, in terms of what they did problem solving wise in this lesson, I really thought they had really interesting responses to that problem, but maybe they weren't engaged in using particular representations that I literally had right out in front of them. And for whatever reason, perhaps comfort level, perhaps lack of understanding about how to use it, they didn't do that. Maybe I want tomorrow to make something that's a little bit more direct in use of that particular representation. So I think, to your point, the notion of using, I'm just going to say what it is, formative assessment to sort of monitor where they are in that process is really important. And
Absolutely.
what you plan and anticipate they're going to do within the lesson, how they're engaged in that problem, you know, how are you going to set up the problem? Does the problem kick off the lesson? Does it occur midway? Does it occur, you know, towards the end of the lesson? Those are issues too around the planning perspective.
Okay, that's perfect. That's perfect. I just happened to, we'll answer that in a minute. And somebody just sent a good question, so my eye wandered. I should close that. Okay. So we know that, you know, we know that the students struggle with problem solving, and I think it's for a lot of different reasons, some of which I, you know, walked through. In your opinion, what are the biggies that that are in the way of them really getting to that higher level of being able to approach a problem effectively and flexibly? Like, what are the things that you think are the biggest hurdles for them?
Well, I mean, let me take a shot at your question first of all. I don't know that everybody struggles with problems. I mean, I think teachers are constantly surprised at kids that frankly may not have the prerequisite skills, that for whatever reason see stuff. They're able to see where that thing is, even though they don't have the prerequisite stuff to necessarily get through all of that. But to your point, yes, you know, what kinds of problems are they struggling with? In other words, is language an issue? I mean, is it a readability thing? Is it an issue with a number of second language children who just don't have the opportunity and the fluency that you would like them to have with the English language and so forth and so on? So what, you know, those are just two examples that I'm going to cite. And I also will cite the fact that it depends on the complexity of the problem. I mean, sometimes we do ourselves a disservice by making problems that frankly are ridiculous. I mean, have for decades, I always say, you know what, before you run that in front of a kid, please read that problem yourself and make sure you know you know it. And I can't tell you how many times I say, oh my God, I can't believe I did that. I left out half of a sentence or whatever. No kid's going to say. Right. So the notion of, is this an appropriate task for your class? Okay, good. Are there issues? I'll go back to what I said. Are there issues related to language? Okay, fine. Let's you know that up front. Maybe this this class's engagement with that task, I'm going to have them work in pairs, and so they can work with each other, if you will, in the decoding aspect of the problem. And then I'll go back to what I said earlier. You'll find once kids sort of see the path, they can go a lot faster than some other kids who might be better with, if you will, the skill-based notion of mathematics and not necessarily the applications, which is what we're talking about.
Yeah, no, that's true. That's a good point. The difference in productive struggle and just struggle, right? The complexity of the problems. Yeah.
And by the way, that's a great point. In other words, I think one of the challenges of teaching is that, you know what, frankly, if it's a really good problem, you want them to struggle a little bit, because I mean, a problem is an obstacle. A problem is something in front of you. It's sort of like that rock in the middle of the road or whatever. You have to work your way around that. And frankly, if you can go right through it, then it's not a problem. It's an exercise. And by the way, once you knows that, nobody's so gifted that they have this great problem that's going to be really good for everybody. Some kids are going to fly through problems anyway. Some kids are going to get stuck anyway. So it's the mix of that. But so, you know, ensuring that whatever it is sort of appropriate for your class to some extent comes with experience.
No, for sure. Yeah, still gives them a chance to, you know, succeed. Can they get to the end point at some point, right? Yes. So then how often should students partake in like just, and this, I'll be curious to hear your answer, just, you know, really authentic problem solving? Is it something that they should be practicing every single day? Is it something that you know, like what are some ways that teachers can implement more consistent practice with problem solving, and really how regularly should they be doing it, and probably just focused on K-5?
Yeah, well, I mean, there are people who have talked about, frankly, for decades, problem-based instruction, where, frankly, every lesson begins with a problem. Every lesson is set up by a task that sort of is introductory to the lesson, and the kids work through it or what have you. I think people have taken that model and done different things with it. In other words, one of the things that I think is important for kids to understand, not so much at the primary level, but certainly at, say, grades 4 or 5 and on into middle school and so forth and so on, then that, you know, a good problem is going to take a while to solve. I mean, all of us remember some mathematics class at the undergraduate level or the graduate level where, oh my God, you know what? I got to get up and I'm done with. I got to walk away from this problem for a while. I'll come back to it, and voila, I come back to it X minutes, X hours later, and all of a sudden it makes sense to me. Well, you don't have that. You don't have time enough to do, if you will, that in the elementary school classroom. But at some levels, again, upper level elementary, you may have a problem that you'll introduce one day, and you'll just have them start it and carry it through the next day. You know, to send a message that, you know, let's have people work together. Let's share group ideas and so forth. Let's come back and see if we can chart up a variety of different solutions, because I think one of the key aspects of problem solving is that kids are engaged in problems where they can see multiple paths to solving that problem and think about those. And by the way, teachers, the kids are generally more readily picking up on some other kid's strategy than something we tell them to, because frankly, we're adults and, you know, they would rather do a buddy solution or something like that. So I think that's important. But to my way of thinking, of kind of a backward way to address your question, I think problem-based learning appears somewhere in a lesson every single day. Maybe it's the exit task of the lesson that gives you a sense of where they are with regard to that concept and helps you in your planning for the next day. Maybe it drives the lesson, you know, but I think there are opportunities throughout lessons to engage students in the problem-solving process, regardless of grade level.
Okay. I agree with that. I also think that you're right. If they share their strategies or they share how they solved a problem. If I have a kid that's struggling, he might be more likely to try his friend's way, right? He didn't get it, but he might try that way over mine. That's a very good. I mean,
I can't tell you how many times I've been in classrooms with teachers where kids will say that, oh, I really like such and such strategy. And I've been telling you that for 3 days. You know, all of a sudden you like that person's strategy, so it's fine, you know.
Totally okay.
The
So
way
I'm
it is.
going to switch over just because we have a few really good questions that I want to answer, and time quickly goes. So thank you guys for putting in these questions. I'm going to try to go through these. Let me start with,
By the way, this just in case anybody wanted, this is water.
okay, this is coffee and it's 4:30. I should not even be drinking it. Okay.
5:30 my time, so if up to 5 o'clock.
I just can't get warm in Chicago. The weather is not good, but I think that that's everywhere. Due to virtual distance, we are, so I have, let me just make sure that I'm reading this is 2 parts. Okay. Due to virtual distance learning, we are okay, you know what, I'm going to go to the next one. How do you have students respond to problems remotely that could support a teacher's way to monitor student progress?
Yeah, first of all, it's a great question, and it's very much an everyday question these days. And I'm involved in some projects that are doing, if you will, some of that. What I'm finding people doing is having kids taking a picture of their solution and or doing a video of the solution process for a technique I refer to as a show me technique. And I say, show me how you did that, and they can do that, and you can do that. You can set that up. I mean, we're in situations where we set that up, either individual child. And here's the negative about that: you don't have the time to look at 30, even if they're short videos of 30 kids on a regular basis. You may want to do that once a week or whatever. Again, that's your call. But as you put kids in small groups, you get almost to the same place, and you have far fewer of those to deal with. Another thing I find people are doing is taking a picture or a video of a dock camera and kids working that way. Again, these are things that we're learning this academic year that for a whole lot of people they never thought about last year. So, and there's probably more. I mean, I see different apps. An app that I use in my work in formative assessment is GoFormative or Formative, where you can do some of what I just said online. And there are a number of apps, if you will, like that that you could think about as well. So I recognize the challenge.
That's a good. One that my daughter, their school uses a lot is, I think they do a lot with, like Flipgrid. I know that I love Padlet. I would put a link in in our Zoom meeting with the kids, and I'd have them respond on the wall.
Yeah. And actually, in terms of Padlet, in terms of multiple responses in different routes, that's a great one to just tack stuff on the wall and then sort of organize where you're going to go with your conversation. Good idea.
Yeah, and it lets them see what you just said, right? What did their peers say, right?
Exactly.
About Good question. How do you view problem solving when for students who are in tier 3 for math and have huge gaps in prior knowledge?
Yeah. First of all, I'm involved with a colleague of mine who, her name is Beth Corbett. She's on the NCTM board of directors, and she's written a book around strengths-based teaching. And Beth uses the phrase strength spotting, that regardless of if you will, tier, kids have particular strengths. And I think that's your starting point, recognizing very deliberately, because I have taught children in the kind of situation that you're describing here, it's going to be slower, and you can't do as much within a particular confined period of time that you might have, whether that be face-to-face or hybrid in for sure. On the online side of that, if there are ways for you to get them engaged with activities, if you will, offline, to do some of the catching up that they need to do, I would certainly encourage that. And not to advertise this in any way, but what Kristen presented in terms of the 5-day sequence of the problem-solving activities that Hand to Mind has been working on, I would think, my opinion, that some of those deliberately, and you might go out of order, if you will, but I think they would address very nicely some of the concerns that you have.
Yep, and help with those when they're the tier 3, sort of starting with like the even just the picture, right? Just talking through what do they see? And starting it that way, even I could see that with students who are, missing a lot of the prerequisites.
Well, I mean, and even because I like very much the numberless problem that presented, and the whole notion of having kids just talk about problems without numbers. That's important, and forget tears for a moment. That's important for everybody. But that in situations like that, there's no penalty. You can everybody has the same starting point with that, and so maybe that's a way as well to get because I think we have to be honest here. You want those kids as engaged in the mathematics learning opportunity as everybody else. It's going to be just more challenging to find the kinds of activities and frankly the starting point to get them moving ahead.
So that leads into the last question, which is just the struggle with engagement, just in the current environment, just a general struggle with keeping them engaged in learning math. Yeah. Suggestions, tips?
Well, I mean, I've seen, and you have too,
I know.
teachers who are, seemingly standing on their heads. This morning I watched an instructional assistant from Frederick County, Maryland. We're not too very far from where I live, who was doing raps about mathematics to get kids engaged in mathematics. And I'm not suggesting that you do that. I could not do that. But I mean, I think you have to start with your own strengths in terms of what are you using to sort of say, okay, as I think about that math lesson tomorrow, what is it about that lesson that's going to engage kids in doing this mathematics? And given the situation that you have, and I don't know whether you have this, but I have teacher friends who frankly don't see their kids because they're not making themselves live on the video. And so what is it about the context? Maybe it's the context. Maybe it's organizing problems that's about, if you will, them and their school and or particular events at their school. Anything to sort of get at something that they might be interested in. I mean, I've always been a fan of, let's make sure you know the things that your students are involved in, outside of the school building, and even in these times they're doing something. And so, is there a way to sort of tap into that as context for problems or something like that? But yeah, I mean, I can't claim, nor can anybody else, that there are answers to this question. I can understand and recognize that you're all doing heroic work, and I know my grandchildren appreciate it, and I know children around this country and their parents appreciate it, and if they don't, they should.
Absolutely, absolutely. And just doing a lot of different things, trying a lot of things outside the box, and it is there. I say this: teachers are nothing if not the most adaptable human beings on the planet. So things change and you adapt, and we love that. So they have things in their hands.
I'm writing this article. I'm a long ago basketball player, and I'm using the word pivot a lot. Not the way pivot is supposed to be used in coaching and playing basketball, but pivot in terms of what teachers are doing literally every day. I plan to do this, and snow came. I plan to do this, and the hybrid thing, but only 3 are there, and everybody else is online, and so forth. So the notion of having this great idea of how you're going to engage your kids in doing mathematics, and all of a sudden immediately you got to pivot and do something else. I mean, I get that, there are lessons here that you're learning that you will take through the rest of your career, I guarantee you.
Absolutely, absolutely. Well said. Okay, I think that is it for today, you guys. Those were such good questions. So thank you, Skip. Thank you for joining. Always the best. We are, if you attended, you will get this recording. You'll also get a follow-up email with an attendance certificate. If you're watching this recording, you won't get the certificate, but you will get the link if you registered. So Michelle Mule, you are the winner today. So I'm going to reach out to you via email as a follow-up with your prize. And yay, everybody loves to win. We wish everybody, a good rest of the day. Stay warm and join us in a couple weeks for the next one. Thanks, Skip.
Yep, bye.
Take care. Bye-bye.